This is Radhika. I am going to discuss about power electronics subject. This is for electrical with some students. In this class, we are going to discuss about the applications of electronic circuits. Under this, we are going to discuss about the power electronics applications, and also we are going to discuss about the types of disturbances. So in this, previously we discussed about the basics of power supply and power supplies characteristics. Today our main topics are types of disturbances in power supply and devices used to suppress spikes in power supply voltages. So actually what is disturbances? So before going to this one, we can discuss about the some introduction of applications of power electronics. So in this, so here in this, actually what is the applications of electronic circuits? Nowadays, high quality, regular and uninterrupted power supply is a basic requirement of all types of power consumers. That means it will be used in commercially, industrially and domestic purpose. But the power quality means voltage level, frequency, harmonics, free voltage, etc. deteriorates and the supply is affected due to power blackouts and power failures because of poor maintenance of power distribution companies. The power outage and blackout are becoming very common. So critical loads such as computers, hospital hospital equipments, including pre and post surgery medical care systems, processing control systems in industries and communication systems, require a continuous and quality power, otherwise, a major losses will occur in computers, and sometimes life of human beings may also get affected in operation theaters due to power failures. Hence, critical loads require con- critical load requires conditioning and uninterruptible power supply UPS for satisfactory and reliable operation of these loads. In general, a regulated DC power supply is needed for linear or analog or digital IC based electronic circuits and control systems. For this purpose, conventional or linear power supplies are also available, which is a, DC, which is a AC to DC converter, where output DC voltage is maintained. In this chapter, some of the special applications of power electronic devices such as illumination level control using SCR, light dimmer circuit, theft alarm circuit using SCR, and battery charging methods using SCR are studied. Now here we have few applications of power electronic circuits that are the thyristors were widely used in many number of applications in the fields of power electronics. So we have few applications are high voltage direct current power transmission system, light dimmer in home and theaters, light charging or battery charging circuits, burglar alarm or theft alarm circuits, electric traction vehicles such as tram cars, trolley cars, subways, electro locomotives, etc. Commercial lighting and speed control of AC or DC machines, static circuit breakers, power control in chemical processing using electrochemical process such as electrolysis. Power control in metallurgical process using electrothermal processes such as electric arc melting, arc welding, induction heating and melting resistance heating, etc. Power supply for aircraft, space shuttle and satellites. These are the few applications of power electronic circuits. Now we are going to discuss about the disturbances. Actually, what is the disturbance? Here in this, so here actually what is the disturbance? The disturbance is a deviation from actual value of voltage and frequency. The disturbances in the power systems may occur for short as well as long duration. Means here the disturbances in the power system may occur for short as well as long disturbances. There are different types of disturbances. They are voltage deviation, frequency deviation, voltage spikes, harmonics, chopped distorted voltage, electromagnetic interference means EMI, and power outage and blackout. So now we are going to discuss briefly about above disturbances. Now first we are going to discuss about the voltage deviation. So in this the in voltage deviation, if supply voltage is less than the nominal voltage called low voltage, poorly maintained poorly maintained distribution system experiences low voltage problems during the peak hours. And also, if supply voltage is higher than the nominal voltage is called over voltage. Our voltage problem Over voltage problem for few cycles is not a serious problem, but for longer duration it damages the equipment. So here in this, the voltage deviation, low voltage problems may arise during peak load hours. Over voltage problem means the supply voltage is higher than the rated voltage. It exists for a few cycles, then it is not a serious problem, but for longer durations it damages the equipment in the system. Next is the frequency deviation. This is another bad quality of poorly maintained power supply. It affects highly the performance of AC motors. The permissible limit of frequencies plus or minus 5%. If the supply system frequency is not maintained within a permissible limit of plus or minus 5%, then the performance means speed, torque and magnetizing current of the motor get affected badly. Next is the voltage spikes. So it is a sharply rising voltage pulse superimposed over the main supply voltage waveform. These will appear for very short duration. The voltage spikes are mainly occur due to lightning strokes or due to transient switching actions. It is a sharp voltage pulse superimposed over supply voltage that exists for a short period of time. It is mainly due to switching transient voltage of circuit breakers or lightning strokes. So this is the diagram for voltage spike. Is the here it is the sine wave of voltage, and here this part is called voltage spike due to lightning or switching operation voltage, and this is the actual main voltage. Next is the harmonics. A distorted supply voltage waveform contains high order harmonics. Nonlinear loads of bulk consumers causes voltage harmonics. SMPS electronic ballot CFL vapor lamps introduce harmonics. The harmonics are mainly developed due to usage of nonlinear loads, switch mode power supply SMPS, electronic ballast circuit in vapor lamps, and CFL compact fluorescent lamp. Due to these type of loads, the supply voltage waveforms is distorted and contains high order harmonics. So here these are the presence of even and odd harmonics. Here is the sine wave. This is the dotted lines is the pure sinusoidal voltage waveform, and the AC actual mean. So is the some disturbances is the harmonics. The harmonics are usually odd, may be even in some cases. It is not same in positive and negative half cycles. Next is the chopped distorted voltage. It is a deviation of voltage waveform, pure sinusoidal waveform. These are mainly caused due to usage of high frequency AC voltage choppers, sometimes due to electric arc furnace and welding transformers. Switching or chopping of supply voltage and then reswitching once or repeatedly cause chopped voltage. This is the diagram for chopping due to phase control. So here dotted lines is the main supply voltage, and black line is the chopped disturbed voltage. So this is the disturbances of chopped distorted voltage. So next is the few causes of chopped distorted voltage. So the causes are a thyristor based phase control of load voltage, a high frequency AC voltage chopper, electric arc furnaces, welding transformers. So these are the few causes of chopped distorted voltage. Next is the electromagnetic interference. So in this it is In this, it is a high frequency noise in the supply line due to lighting, switching of power network, switching of high frequency converters, lightning and voltage spikes of spark plug of automobiles. So and also in this, it is mainly introduced in the power line due to lightning, switching operation of power network, switching operation of high frequency converters, and voltage spikes of the spark plug of automobiles, etc. Due to this, a noise or interference will resulted in the power line. So next is the power outage and blackout. So here the power outage and blackout is: power outage is failure or disconnection of power for a short period of time. Blackout is also poorly maintained utility for a few hours to several hours. So here in this, power outage is a failure or disconnection of power for short period of time without prior notice to the customer. Blackout is a failure or disconnection of a power for a few hours to several days. From the above, it is observed that some of the disturbances are man made and some are acts of God beyond the control of human beings. So, here now devices used to suppress the spikes in supply voltages. Voltage spike is a sharp positive or negative non repetitive voltage pulses superimposed over the supply voltage that exists for a short period of time. Few are the various devices which are mainly used to suppress the voltage spikes in the supply voltage, that are isolation transformers, metal oxide variations means MOV, snubber circuit means RC type, and last is the transformers of voltage regulators. Now we are going to explain about uh, the above four listed. In this, first of all, we are going to discuss about the isolation transformer. In this, it is used to isolate the load circuit from the input circuit. The load circuit becomes electrically isolated and magnetically linked with the source. It offers a large impedance to, to the load to the voltage spikes, hence it suppresses the spikes. It offers a large impedance to the voltage spikes, suppress the higher order harmonics. Next is the metal oxide variations. These are mainly used to bypass a high voltage spikes. It offers a low impedance path when the input voltage spikes crosses the threshold voltage level. It offers low impedance when the input voltage spikes crosses the threshold voltage level. So next is the transformers of voltage regulations. It suppresses the voltage spikes as the transformer impedance is connected in series with the load. The transformer's winding leakage inductances offer more impedance to the voltage spikes as well as higher order harmonics. It offers more leakage impedance to higher harmonics and voltage spikes. So next is the snubber circuit. It offers low impedance to the voltage spikes, hence these are mainly used to bypass the voltage spikes without going to the critical loads, means computer, hospital equipments, process control systems and communication systems. So here in this, so here this is the about these are the devices used to suppress the spikes in supply voltage. So this is the power supply. This is the power supply figure. Basics of power supply, which would give desired constant output voltages. So power supply system should give constant output voltage. Power supply is a basic need of power consumers to get the desired speed, control of drives, to get continuous light without flickerings. So types of power supplies: linear or conventional power supply, linear or conventional power supply, uninterrupted power supply, SMES power supply, linear power supply. It is a AC to DC converter where it gives the DC output voltage. It contains transformer, rectifier and a transistor biased voltage regulator. And also has the drawbacks of linear power supply is these are the large in size, heavy weight, poor efficiency, that will be 25 to 30%, and operation cost is high. Next, bulky transformer, laminated transformer core, bulky capacitors, shielding is required for RF, regulation is 0.1 percentage. These are the drawbacks of linear power supply. To overcome the above drawbacks, the power supply types used are switched mode power supply SMPS and uninterrupted power supply. About this topic we will discuss in next class. So this is the figure for SMPS power supply. This is the internal diagram of SMPS circuit and power quality characteristics. These are the constant magnitude of voltage, constant frequency 50 Hz, and it has the balanced three-phase supply, and it is the pure sinusoidal waveform, and is the no transient or no spikes. So now we can watch the one YouTube video regarding applications of electronic circuits.
In case of our home, if you see, we can find a number of applications which are having star ratings. These star ratings are given by an agency named BEE, that is Bureau of Energy Efficiency. As the name suggests, these ratings are given to the devices which are having high efficiency. Now this high efficiency is achieved with the help of power electronic converters which are fitted inside the devices. In our refrigerator, we are having compressors. Also in air conditioner, we are having compressors. These compressors are run by power electronic converters. In case of lighting application, all of us are nowadays moving towards LED lighting. LED lights are driven by power electronic drivers. Vacuum cleaners, they are also supplied by power electronic converters. In our television, we are having LCD television or LED television, which are dominating the industry these days. In both LCD as well as LED television, the power supply is controlled by power electronic converter. The cooking appliances, which is widely used in our kitchen, that is induction cooktop, is controlled by a power electronic converter. So in home application, we can find all these applications In the aerospace industry, the applications of power electronics are aeroplane power system, space vehicle power system, satellite power system, space exploration robot power system. Let us first start with the aeroplane power system. You must have heard about the aeroplanes which are powered from solar power. In those aeroplanes, solar panels are mounted on the top of the aeroplane. Solar power generates electrical energy from the solar energy. That electrical energy is transferred to the motors with the help of power electronic converters. Motors runs the fan, and in that way the plane flies. In case of normal turbine based aeroplanes also, power electronic converters are used to reduce the size of the electrical equipment. In space vehicle power system, power electronic converters are used for powering the computers and other electromechanical systems through battery. In satellite power system, again there are some solar panels which are fitted on the satellite for generating electrical energy. Power electronic converters are used for maximum power point tracking of that solar panel, with the help of which batteries are charged, and when the power is required, again other power electronic converter takes that power from the battery and supplies it to the different systems available in the satellite, such as cameras, transmitter, receivers, etc. In case of space exploration robots, there are different electromechanical systems required for the movement of the space exploration robot as well as communication purpose. For powering these systems, power electronic equipments are used. Space exploration robot, as it is not having any direct connection with the earth, it is again relying on the solar power. So the batteries in the space exploration robots are again charged with the help of power electronic converters and solar panels. In the automotive sector, in earlier days, electric vehicles were not that popular. The reason behind that was the range of that electric vehicle. The range of electric vehicle in earlier days was very small, of around 30 to 40 kilometers. But nowadays, with the development in the battery technology as well as the development of power electronics, the range of this electric vehicle has extended to around 300 kilometers, which is a very respectable range. In case of electric vehicle coming from the battery charging, power electronic converters are used. Power electronic converters are available for fast charging the battery as well as slow charging of the battery. Once the battery is charged and vehicle is ready to run, for running that vehicle, electric vehicle drivetrain which is used is made up of power electronic converters. A very important feature in electric vehicle, which is regenerative braking, is made possible because of the power electronic converters. When the electric vehicle is running, the battery is managed with the battery management system, which also consists of power electronic converters. The auxiliaries which are available in the electric vehicle, or say any other vehicle which are powered from the battery, are supplied with the help of power electronic converters. In case of electric vehicles, these auxiliaries consist of air conditioning systems, entertainment systems, protection system of that vehicle such as central locking system. In industrial sector, let us move forward our discussion with the application of power electronics in fan and pumps. Consider that we want to control the flow of a particular fluid. That fluid is pumped with the help of a particular pump. To control the flow of that fluid, we will be using a damper or a valve depending on the nature of the fluid. If the fluid is gas, then we are going to use a damper, and if it's a liquid, we are going to use a valve. Now, we know that valve as well as a damper are analogous to resistors in electrical systems. Whenever current flows through a resistor, there occurs a power loss in a resistor. Similarly, when the flow of any fluid is controlled with the help of a valve or a damper, there occurs a power loss. Then how to reduce this power loss? We know that if the speed of this pump or fan is reduced, we will be able to reduce the flow of the fluid. If we are able to increase the speed of the fan or pump, we will be able to increase the flow of fluid. So, for increasing the speed of fan or pumps, we are using variable frequency drives which changes the speed of motor which is driving the pump or fan. In this way, with the help of power electronics, we are able to control the flow of a fluid without causing power loss. Another advantage of it is, if we are reducing the speed of the motor, the electrical energy required for driving that particular load by the motor will also be reduced. In this way, the efficiency of the entire system will be improved. Now, in case of furnaces, in earlier days, we were going for blast furnaces. Blast furnaces create pollution. Along with the pollution, the time constant required for heating up the blast furnace is also very large. Compared to that, induction furnaces, which use power electronic converters, have very small time constant, and the pollution can also be avoided with the help of induction furnace. Hence, industry has moved on to induction furnaces. Next application is electromagnet. In the shipyards or in the shipping industry, when we want to lift huge metal containers which are used in the shipping, we are going for electromagnets. For powering those electromagnets or controlling the electromagnets, we are using power electronic converters. Different drivetrains used for driving various motors in the industry are again made up of power electronic converters. The UPS system, which is also known as uninterrupted power supplies, are also made up of power electronic converters. In medical industry also, power electronics has got wide range of applications such as MRI scanners. MRI scanners are used for scanning of a patient's body with the help of huge amount of magnetic field. This magnetic field is created with the help of large currents flowing through a particular coil. For controlling the magnetic field, we need to control the current flowing through that particular coil. This controlling of current is done with the help of power electronic converters. Various lasers which are used for the surgeries are also run by the power supplies which are made up of power electronic devices. Power supplies to various monitoring systems used Power supplies to various monitoring systems are also made up of power electronic devices. These monitoring systems are used mostly for monitoring the stability of a patient. The fitness equipment that we are using in our day-to-day life are again powered by power electronic converters. In case of transportation industry, power electronic has got applications in electric locomotive, maglev systems, motor drive systems. In case of locomotives, power electronic converters are used for driving the motors fitted at the axle of that locomotive. The motors fitted in the axle of locomotive, they need to produce a huge amount of torque for driving the entire train. Controlling of that particular motor or motors is done with the help of power electronic converters. Motor drives used in tram systems as well as electric buses are also made up of power electronic converters. Maglev systems. Now maglev system has got a wide range of possibilities in near future. A very good example of maglev system is Hyperloop, which is being developed by a businessman in USA named Elon Musk. Hyperloop has got a tunnel inside which a capsule will run at very high speeds with the help of maglev systems. Maglev is magnetic levitation. For creating a huge amount of magnetic field, we need power electronic converters. In power utility system, power electronics is used for maintaining the stability of power system as well as improving the power quality of the power supplied by the power system. Power electronic converters are used in STATCOMs, power factor correctors, VAR compensators, static circuit breakers. In case of HVDC converters, power electronics is used for transforming the power from AC form to DC form and transmitting it to huge distances with higher efficiency. Along with that, HVDC converters are used in some places for connecting two different grids which are running at different frequencies and which are located nearer to each other by means of geographic location. In telecommunication sector, power electronic converters are used for powering the transmitters and receivers fitted on mobile towers. Power electronic converters are also used for charging our mobiles. These power electronic converters are fitted inside the mobile chargers. Because of this power electronic converters only, the weight of the mobile charger is going down and down day by day. Power electronic converters are also used for charging the batteries of the wireless systems such as walkie-talkies, used by emergency response teams such as police, ambulances, fire systems, etc. So, at last, if we raise a question, where can we find the applications of power electronics? The answer to this question would be almost in every sector where electricity is present. So, in this lecture, we have seen applications of power electronics in
So we watched the YouTube lesson for application of electronic circuits. Now today our class of the summaries we learned basics of power supply, linear power supply, drawbacks of linear power supply, and power quality characteristics. And also here we have the few quiz questions and frequently asked questions that are state any four devices used for suppressing the voltage spikes, and our second one is the state any four causes of disturbances in a power supply system. So this is the class for applications of electronic circuits. In next class, we are going to discuss about the UPS, online UPS and offline UPS. Thank you.